Have you ever wondered what lies beyond the edge of the universe? Well, to tell you the truth, there is no edge to the universe. Imagine you're in a spaceship going through space. You keep going, but no matter how far you fly, you never reach an edge, like a wall or a boundary. But why? Well, the answer is both fascinating and mind-bending. So let's get started. My name is Siddharth, and you're watching The World of Science.
The key to understanding the edge of the universe is that light travels very, very fast, but not infinitely fast. It takes time for it to get from one place in the universe to the other.
First, let's get one thing straight. Based on our current knowledge, the universe is infinite. That's right, it goes on and on forever. That's because space spreads out infinitely in all directions, and the galaxies fill all of the space throughout the infinite universe. But wait, how do we know this? It's a logical conclusion that's been reached by combining two observations. The first observation tells us that the part of the universe that we see is uniform and flat on the cosmic level. The uniformity of the universe means that the galaxy groups are spread out almost evenly, and the flatness means that the geometry of space-time is not warped or curved. This means that the universe does not wrap around and connect to itself like the surface of a sphere, which would otherwise lead to a finite universe. But hold on. We do know that the force of gravity is due to the curvature of space-time caused by mass, right? Well, the flatness of the universe is actually due to the uniformity of the universe, since concentrated collections of mass cause the space-time to be curved. The planets, stars, and galaxies, they all are examples of concentrated collections of mass, and they do warp space-time around them. But on a cosmic scale, these objects are so small that the space-time warping that they cause is negligible. Now, the second observation tells us that there's absolutely nothing special about our part of the universe. Since our part of the universe is flat and uniform, all parts of the universe must be flat and uniform. And the only way for the universe to be flat and uniform literally everywhere is for the universe to be infinite. And that proves the point that the universe has no edge. But wait, you might be thinking, how can the universe have no edge if it was created in the Big Bang? If the universe started as finite in size, shouldn't it still be finite? So here's the tricky part. The universe did not start out as finite in size. The Big Bang wasn't like a bomb that exploded from a single point of detonation, as it did not happen at a single point in the universe. It happened everywhere in the universe at once. One piece of evidence lies in the aftermath of the Big Bang, that is the cosmic microwave background radiation. This radiation exists everywhere. The explosive expansion of the universe wasn't the case of any physical object expanding into space. Rather, it was the case of space itself expanding. The universe started out as an infinitely large object, and it has grown into an even larger infinitely large object. Sounds weird, but it's true. While it is difficult for humans to comprehend infinity, it is a perfectly valid mathematical and scientific concept. However, we humans can only see a part of the entire universe, which we call the observable universe. Light travels at a finite speed, so many objects in the universe are simply too far away for light to have had enough time to reach us since the beginning of the universe. And since light travels at the fastest speed possible, there is no kind of signal or information that had the time to reach the Earth from these faraway points, and so such locations are currently outside of our sphere of observation, that is, our observable universe. Every location in the universe has its own sphere of observation beyond which we cannot see. And since our observable universe is not infinite, it does have an edge. But that doesn't mean that there's a wall of energy or a giant abyss at the edge of our observable universe. The edge is simply used to mark a line between the locations that we can currently see and the locations that we currently cannot. And although our observable universe does have an edge, the universe as a whole is infinite and it does not have an edge. As time goes on, more and more points in space have had time for their light to reach us, which means our observable universe is constantly expanding. But there's a catch. The universe itself is still expanding, and all galaxy groups are getting farther away from each other. Some galaxies are so far away from Earth that their expansion causes them to recede from Earth at a speed faster than light. While this may seem like it breaks the laws of physics, it actually doesn't. Special relativity prevents two local objects from traveling away from each other faster than the speed of light. But on the other hand, it doesn't prevent two distant objects from traveling away from each other faster than the speed of light due to the expansion of the universe itself. Since these distant galaxies are receding away from Earth at a speed faster than the speed of light, the light from these galaxies will never reach us and will always be outside of our observable universe. Another way of saying this is, although the size of the observable universe is increasing, the size of the actual universe is also increasing. The edge of the observable universe cannot keep up with the expansion of the universe as a whole, and so many galaxies will eternally be beyond our observation. The universe is an endless expanse of mystery and wonder, and we're just beginning to scratch the surface of its vastness. We may never be able to see the entire universe, but we can certainly appreciate the sheer scale of it. So the next time you look up at the night sky, remember that you're staring into the boundless depths of space with no edge in sight. Did you find this video interesting? Let us know in the comments. Make sure you subscribe to the World of Science. Until next time, stay scientific.